see the Go community growing in Utah. Um, been going to Go meetups in Utah since like 2014. It was a much different crowd back then. We were meeting up at I forget the name of the place. Yeah, Rakuten up in Common Heights area, their space, and it's kind of neat to travel around. And it's awesome to be here on the local Go conference in Utah. So that's super awesome. It's what a great community. A little bit about myself. There we go. I've been writing software since I could talk, almost. Not quite true, but for a really long time. Got a PhD in electrical engineering at Purdue, so I love the Game Boy Advance talk. I love hardware. I don't get to work on hardware very much anymore. I'm not as motivated as some people are to get into the dark corners of the internet and work on things just because you can. But it's a little inspiring. Love software. That's why I'm working in software. I love observability systems. Tracing is like one of my favorite things ever to work on. So whenever I get a chance to work on a tracing system, I'm like, this is the greatest thing ever. How fun. Most people don't say that. Love to ski. Trying to get into surfing. Not good at it. I got some Google stock photo pictures on the side there. None of those are of me or things I've worked on, but they represent my interests. My hobby is programming. So like Nate and I like sit on program for fun. Super fun. I work for a company called Kala. We are hoping to make integrations a whole lot easier for people because let's be honest, they're a nightmare. They're all bespoke. They're all a mess. So Clint and I over here started a company called Kala. We are working on an integration platform. We want to be the Zapier for all the integrations that Zapier won't ever touch because they're horrible. But that's kind of what we're working on. So give us a look if you want to see more of what we're doing. We've got a new landing page coming up soon, so it'll actually describe what we're doing instead of what we thought we were going to be doing. All right, let's get into testing. Raise your hand if testing is your favorite part of your job. Awesome. Cool. Testing is cool, right? It's super cool. It's super awesome. Like we should all just do testing. Why do we do testing? Because we want to develop code faster, right? We want to get our code out faster. We want to see the outcome of our code. We want to do things faster. So like, if you have good testing strategies, you can do things really fast. If you want to do things really slow, what you do is you write your code, you commit it, push it to GitHub or GitLab, you wait for your CI/CD system to run, maybe get it up on a box somewhere else, go and hit a URL by hand, and then later like, yeah, code didn't work. All right, let's do that again. Like, that's not fun. So when we're talking about testing, I'm not talking about stuff like that. Why do we do testing? Because we want to deliver value. That's why we're getting paid to do this, is to deliver value to someone. It's our customers, our employer, or someone. Someone's paying us to do this. So it's our responsibility to deliver that value quickly and efficiently. We do testing because it's part of our code storytelling. We went to a great talk at GoverCon. It was really inspiring. She talked about writing code as telling a story. And you want to write your code clear, concisely. You want it structured so that when someone comes in a year later, 2 years later, next week, they can go through and they can read it and understand what's going on. So that means having the right layers of abstraction in the right places. So that when you're looking at a function, you're like, oh yeah, Sally went to the market, Sally got in her car, Sally bought some lettuce, Sally went home and made a sandwich, right? That means awesome. No one wants to read a story and say, oh, Sally got in her car, she opened the door, she put the key in the ignition, she turned it, she pushed on the gas pedal, she steered, she walked in the store, it took 20 steps to do that. Like no one wants to read at that level of detail when they just want to know, what is Sally doing, right? So right level abstraction, right places. If you want more details, you can dive into functions and find those details elsewhere, but maybe not in the main part of the story on what you're doing. So that was super cool. And it really works well with testing because if you have good storytelling in your code, it makes testing a whole lot easier. We do testing because we want to manage the risk of delivering our new code, right? You can write a bunch of code and just YOLO, throw it over the fence and say, I'm done, this is great. And then hour later, you hear people screaming down support and they're like, oh no, what's happening? Our phone lines are overloaded, we can't do anything, right? And you're like, yes, I won. Could be fun. Testing helps us maintain code quality. That goes back to the storytelling. So if you have testable code, your code quality is likely to be better because you actually put some thought into the structure of your code. And then the testing around our code, it also provides context to what our code is supposed to be doing. So if you want to see how a function's supposed to be used, sometimes you can turn to the tests that are written around it and say, oh, that's how it was intended to be used. And I'm not using it that way. And that might be why I'm having problems with it. It's because it wasn't built in that context of what I'm trying to do. Or maybe you can say, oh, if I hold it a little bit differently, it'll work a little bit smoother for me. So those are all some of the reasons why we do testing. Hopefully it kind of broadens our views of it. That's a empty slide. Oh, it has a transition. Yes, cool, transitions. Testing is a whole wide spectrum that we have to navigate, right? There's so many different types of testing that we can do and should be doing. And it really depends on the context that we're working under. Testing's more than just having a unit test. Testing's more than just having a QA engineer who's going to review your code for you, right? There's a whole spectrum to testing. We have unit tests. Unit tests are small, they're focused, they have minimal dependencies. They're part of our code coverage analysis reports that some of our DevX people force on us. And they really shape how we write our code. We have integration tests. Those are broader. They involve multiple systems. They guarantee that your code is working well with the database, it's working well with the cache, it's working well with the ingress router, working well with all those other pieces and components that are all outside the scope of your direct code. We have non-functional tests. These are going to be security requirements. Are we restricting access to people who shouldn't have access to things? Are we creating audit logs we're supposed to? Are we feeding the data into the SIEM system for the security people so they can fire off alerts when they notice someone's just crawled over 1 million profiles, right? That's kind of a non-functional. It's not for the product, but it's for the auxiliary operations of the company. We have performance, scalability, availability testing. Can our code scale? Can it handle the load that we expect it to have today? Will it be able to handle the load we expect it to have in a year or 2 years, right? That's a different type of testing than unit testing. And then availability, is our code still running? Like, I don't know, is my code running? Maybe. And then user acceptance testing. Does it provide joy to our customers to use our code? Does it meet the checklist that our product and designer people, set out to give us? These are all the different types of testing to work on and to navigate. And we need to make sure that we don't have a really narrow view of what we consider to be testing. All right, so how do we establish a testing strategy, right? I think in general, especially for me, like I don't spend enough time thinking about what my testing strategies are going to be up front. And sometimes they get pushed off to be an afterthought. And so came up with a bunch of ideas of things we should be thinking about as we're writing new code to determine what our testing strategy should be. Is it something we're going to throw over the wall to our QA testers and say, hey, you know what, there's too many things involved and it's not worth the company's time for me to write unit tests because I have to mock out 30 services. Maybe it's okay to push that off to a QA person and be a part of a manual thing, or maybe there's something else and it's like, yeah, this is a unit test because I need it because it's going to get called 1 million times a second and it has to work every time. Love those transitions. Okay, we need to understand the context that our change is happening under. Is it new code that we're working on? Is it old code? Is our new code that we're working on today going to become old code in a week and we're still working on it and then we forgot the stuff we worked on earlier? Yeah, we need to understand that. We need to understand how much investment the company is going to make in this set of tickets that we're working on. So we pull a ticket off of our ticketing system. How much time does the company want us to work on it? How much time is budgeted for it? If they budgeted it a day for it and we take 2 weeks on it, that's not cool. It's going to get us in trouble, right? No one's going to be happy with that. How much cognitive load are we introducing into the system with our changes? Maybe we want to refactor a little bit more so that we can make sure that the next person come in doesn't get like just ambushed by, oh, this code's all about this one feature, except this section of code here is totally different, and I'm not sure what's related, and there's no comments, and I don't understand what's going on here, and I'm just terrified to death to work on this code. Who's the code for? What's it for? How often is this code going to be worked on? That can also impact it too. Is the code going to be touched again in the next year? Is there like a well-developed roadmap where there's like 5 phases of the project that are going to be followed up on this particular code? That all impacts on how we code it and how we test it. How much risk is associated with the change? Is this going into a high volume pipeline where if I stutter, if the code stutters and takes a little bit longer, it's going to just cause a huge backlog in our pipeline? Or is it, a sign up form and it doesn't matter if I introduce latency because the user doesn't really care if it takes 10 milliseconds longer to sign up because we only have one person sign up a day. Like, does it matter? How much support costs are we going to incur from it? What's our operational budget? Are we introducing a new call to some cloud service and is it going to end up costing $1 million a year? Right? Lots of context. And the most important thing to keep in mind is the context is always changing. The way your code is used today may not be the way it's used in a year or 2 years. Your company may look completely differently. And you gotta just understand that the context is always changing. So we make reasonable forecasts, we make our best effort. We don't build out a whole bunch of code that's not going to be used with like 10 new services. It's like, oh yeah, this is all dead code, but maybe in a year it'll get used. Famous saying, you're not going to need it until you need it, so don't build it until you need it. And if people talk bad about your code that you wrote a year ago, just smile and say, you know what, it's in use, it's making money. So that's good code. Good code makes money. All right. How much should the company invest in it? This is a kind of a complicated topic because if you're given all the time in the world to work on a product feature, you can build the best testing framework ever around it. It'll be phenomenal. You can just orchestrate containers coming up left and right and seeding in data and simulating users and load, and you can just do everything, right? But is that valuable to the company? It depends, right? It totally depends. If it could be worth a lot of money to the company, or it might be like, hey, you know what? You get 10 minutes and move on. Yeah. And so you have all these different things. The most dangerous situation to be in is when the budget you're allocated, because to be honest, all your time's allocated by the company. It's when the budget and time you're allocated for a ticket is misaligned with the risk of the change that you're making. That's dangerous territory to be in. And that's when you need to start having discussions with people to help either you or them understand how to bridge the gap between the budget, which is time, and the amount of risk that's being introduced, and make sure you bridge that gap beforehand, because no one wants angry customers. No one wants the company to lose money. No one wants bad things to happen. So that's a conversation starter. How much testing is enough? I think it depends. The best part is that no matter what you do, all your code's going to get tested. It may be by you, it may be by your CI/CD system, it may be by your customers, it could be by the CEO in front of a board meeting, right? Like, you don't know, but it's going to get tested. And so you need to make a conscious decision about who's going to be testing your code for you. The best type of testing is the automated testing that's done in unit tests, but that's really hard sometimes because of dependencies and complexity. But just keep that in mind. Something to consider. I think we covered this. So how much testing questions you ask? It's like determine how much risk is involved in the change that you're making. Lots of risk, you need more tests. If you're in code that hasn't been touched for 2 or 3 years and you look at it and it looks like a foreign language, and you look at it and all the naming's weird because the vocabulary in the company's changed and you don't use those words in the company anymore, and you're like, I don't know what a subscriber means in this context. I don't know what an inventory item is. It's like, this is like totally foreign. You're just totally like out of your league. You're like, I have no idea. That's a lot of risk. Probably need more tests. If there's a lot more planned future work on it, meaning a lot of people are going to be coming and touching this code, you probably want some tests around it to set the context around your code and what it was meant to do. Lots of times we make assumptions about things and code and the way it should behave, and sometimes those assumptions are wrong. And it's really nice to be able to guide future people and constrain them, saying, here's what this code is supposed to do, here's what it's not supposed to do. That's enforced by tests and throwing errors in the code and just making it a friendly code to be worked with. Okay, this is my favorite part. What counts as a test, right? Unit tests. Unit tests count as tests, right? What about when you throw it up into like your GUI and you load the website, you look at it with your eyes, right? Well, that's another test, very manual test. Every time it gets used, every time your code gets run, it's some type of test. So like I've got a very broad definition of tests, and we just need to keep that in mind. Got lots and lots of tools that are available for testing. Observability tools are a great item for testing because those give you your operational behavior tests, right? Your metrics, your tracing, your alerts, your logs. Those are all things that you can observe to know how your code is working, and you can trigger alerts and errors based off of the outputs of all those things to know, is my code working as it's intended to be working? Especially when you have things like in Go where you have, it's really easy to introduce leaking Go routines or leaking memory or leaking file handles. That's where metrics are super important as part of your testing or observability. So you can know, yes, I am leaking Go routines. I've got to go fix something somewhere, otherwise my app's going to crash. Or, nah, my memory's in check, my Go routines are in check, my file handles are in check. This is good. Good code. Benchmarking for performance critical testing. Benchmarking is super useful. A lot of people, I know I'm not necessarily involved with, but benchmarking is not super important for my line of work. But if you're working on a database system or a high throughput system, lots of things, you want benchmarking. So you know, here's the performance before my change, here's the performance after my change. Okay, they line up. End user testing. Especially when we're developing new product features, we have beta customers or alpha customers or like a private preview. That's all part of our testing. It helps us test our user experience. It helps test the functionality. Our customers are always going to surprise us because they can go in with certain assumptions about how things are going to work. They're going to go around, they're going to click in weird places, they're going to put weird data in. And sometimes as a developer, like, oh no, the path is clear. We do A, B, and C. The customer comes in and says, no, I'm going to do E, F, G, and then Z. You're like, oh, okay. I'm going to change things. We're going to make this better. YOLO testing, lots of times they do that. They're like, it doesn't matter. Just deploy it. If someone screams fire, then I know that I need to go fix it, but maybe not. YOLO testing, like, it's useful if I'm like, okay, I'm 99.9% sure based off of my metrics and everything that this code is dead. And then the last step is to delete the code. That's kind of like falls in this category because you're not 100% sure the code's dead, but you delete it, you deploy it, you cross your fingers, you watch the support channels, and you're like, okay, we're good. Or you're like, oh, that report that runs once a week that I missed my metrics, it depends on my endpoints. You're like, okay, I'm going to fix that. But like sometimes getting to 100% confidence isn't the right answer because it's too expensive to get there. So sometimes you just have to throw it over the wall and see what happens. Other side, we get more into our actual code vetting and code analysis. GoVet is a super cool tool. I love that it's built in. It catches a lot of silly mistakes in Go, which is phenomenal. It's like, hey, you're shadowing this variable, or hey, you've got this unused variable here. You know, just all those types of things. There's a whole bunch of linters that are available for Go2 as add-ons that can enforce for specific code style guides. So definitely take advantage of those. Unit tests, phenomenal that Go has unit tests built in. It's not super common in older languages. So if you're looking at like Node or C++ or whatnot, you've got like 30 choices for what unit testing framework to use. And you're like, I don't even know where to start. And then it's like, okay, let's have a 3-week discussion with the team, decide which one we want to use, or then you use it and like, oh, it's not quite right. So super awesome that Go has it built in, and everyone's just kind of like, well, this is just the way it is, and we're stuck with it. And so no choice is helpful sometimes. Fuzzing recently got introduced in Go. It's super awesome for certain use cases. Integration tests, those are your end-to-end testing, manual testing, staged rollouts through different environments or cells of your infrastructure. Super awesome because it helps build confidence in your code as you deploy it to more and more people. Because it's testing is all about managing our risk. And so as we build confidence, we can roll it out to more and more people. So having staged rollouts or multiple cells that you deploy into can be super useful because it kind of, slows it out. Feature flags, super awesome too, because you can get your code out in production so fast. You don't have to do integration testing. You don't have to do manual testing. It's like your code is there and you flip the switch for your user and then you get a special experience just for you within this fully integrated environment. Super helpful. Private beta customers allows the slow rollout for testing, supporting features, and get private users. It's a great tool to use for testing. When you've decided on your testing strategy, so you're going to go through that list, and you're going to pick like 7 or 8 things, maybe, or maybe one, or maybe all of them. You gotta document it because you've got all this information in your head about here's how I, as a developer, developed this strategy for mitigating or managing the risk of the process of this code. And next week, or in a month, or in a year, the next developer to come in, you need to hand off that information to them. So you need to be able to document your code, document your testing strategy, so that others know that the test exists and that they can reproduce those tests. If it's in a PR comment, that can be really hard to find in a year when someone comes in code because they might not even know that PR exists. So even including a link to the PR in your code and the comment around it is like, hey, this code's pretty nasty and tricky, but here's a link on how I did some manual testing to supplement the unit testing that's here. Super useful. I wish I saw that more often, so I highly encourage you to just dump your brain into comments, like super useful. And if people in the future don't find it valuable, they can just go in and delete it. All right, Go toolchain, as we mentioned, has a lot of stuff built into it. We got formatting, embedding, and unit testing, fuzzing, benchmarking. So we'll kind of get into a little bit of that. Sustainable applications are applications that are easily tested. You've got a whole bunch of frameworks and guidelines for ways to guide us towards more maintainable applications. Factor apps, principles in there. Clean is another framework. Dry, wet, solid, test-driven development. Like these are all tools that we can use to help shape the way our code looks. And then when we add unit tests, it helps shape our code too. Most of our code, if you're doing like web APIs or any type of web apps code, your code ends up looking pretty similar to this. You've got an API handler. You're going to massage the input data a little bit. You're going to do some stuff to it. You're going to massage it a little bit more. You're going to throw it into a database or send it off to another API or whatever, get the response, massage it a little bit more, and then send it back to the user. That's kind of the general flow for a lot of web APIs. Super, super common, right? But how you write this code is really going to determine how testable the code is. We'll get into that just a bit. 0% unit test code coverage. Whenever you go into a repo, you're like, oh, there are no unit tests. I kind of just cringe. I'm like, okay, I know what this code's going to look like. It's going to have some fatty blobs of just like dumped code on you. You're like, oh, okay, here we go. The alternative is 100% unit test code coverage. Is a huge misaligned incentive. Whenever I've worked on a couple open source projects where they've enforced 100% test code coverage, and it is such a nightmare to work in because there's a lot of things that are so hard to cover in unit tests. It's like, all right, my one line code changes here, and then I'm going to spend the next 6 hours writing a unit test to simulate a network failure. It's not going to happen because that happens, I got bigger problems. This code doesn't matter. Unit tests, you can have really bad unit tests. A bad unit test is going to be really complicated, or it's going to be really slow. It's going to be really flaky. Flaky meaning that if you run it right now and you run it in an hour, you run it on someone else's computer, you might get a different result. It might have timing stuck in it, and it'll just like fail randomly. And then what ends up happening is people either comment it out or they skip it or delete it. Like, this test isn't worth having. Or yeah, so those are your fragile, non-deterministic tests. All right, so I've got just some blobs on the screen here. Depending on how your code looks, will structure how much unit testing you can do. If your code looks like that big green bubble there, where everything's just like dumped into a pile, you're not doing unit tests on it. Because to do that, you've got to mock out your database server, you got to mock out your external service, you've got to formulate an authenticated request coming in. Like, okay, how do I pretend like I'm a user to my code and pass authentication checks and all these other things? Like, that's just hard. That code's gonna be tested with integration tests by some other system, not in my thing, and that's gonna take longer to iterate on. If we split it out a little bit more, pull some components out, you're like, okay, I might be able to mock out my database a little bit and I can test the yellow bubble. Or the third screen, it's like, okay, really split this out into specific stuff. I put all of my really complicated business logic down in this green or yellow box at the bottom there. That's the code I really care about, because that's really complicated stuff. It's merging a bunch of lists and filtering it and doing some calculations or whatever. Like, and the only input is stuff from the database. So if it takes an input and gives me like a number out, like, I can unit test the crap out of that. It's gonna be awesome. And then I don't worry about mocking my database or whatever, because database is gonna database. Go unit tests. Raise your hand. No, let's not do that. You know how to run them, right? Let's go test, right? Go test. It's one command on your CLI. You should know how to run them. Your CI/CD know how to run them too. We're lazy sometimes we forget to run them, and then our CI/CD system comes back and says, "Hey, you didn't run your unit test because it failed." Like, yeah, you're right. And we got built-in code coverage reports. Most important thing is that testing your important code should be really fast and really easy to do. If it's not, take a little bit of time to restructure your code so that you can get that important business critical code and get some test coverage on it. And Go test is super smart, and it only runs tests when your code changes. So you can see this little test output at the bottom there. It's like, hey, all these tests are cached, nothing changed, you're good to go. I'm not going to waste your time. So the Go people have put a lot of work into making unit testing in Go as fast as possible. So for testing purposes, unit tests can be your fastest tool for iterating on your code. It's not going to be like going to your terminal and sending a curl command to your running server. It's like, unit test is the fastest way possible, but only if your code is structured in a way to facilitate that. All our code, most of our code interacts with external things. Got lots of ways to work with that. You got dependency injection, you got mocks, you got the HTTP test package. You can when your tests run, you can be like, hey, instead of this function being this, I'm going to make my function a variable, and I'm just going to replace it with this new function just for the test, just so I can cut out some complexity. Flags are environment variables that the test set, so you can bypass code. Don't try to do integration tests and unit tests. It's just not fun. It's like if your unit test is trying to like spin up Docker containers, it's like you're holding it wrong. Sometimes it might be easier to test for things that fail and not things that succeed. You're like, okay, I want to test that these 5 things fell, and I don't know how to get it to pass in my unit test environment, but I at least know it catches these important things. And if your test gets super complicated, take a step back, strategize. One of the coolest things about unit tests is you have a built-in coverage report. Your IDE should support showing this test coverage. So you can just hit your toggle in your IDE saying, show me my code coverage, and it'll show you. So if you're looking at this code right here, this code snippet, like there's an error that could be thrown off of JSON.Marshall. Now you'd have to do something really weird to make that so it does throw an error. So don't try to like fabricate a unit test that's going to cover that marshalling error, because it's probably not worth your time to cover it. Like, yeah, it's fine. If someone does something weird, then Jason should catch that in a PR. HTTP client.do. All of those errors are typically going to be like networking stack related. So like if DNS fails or there's no route to the IP address or whatever, like those are gonna get errors. Those are really hard to catch in unit tests. So maybe don't bother. If you have just code that's like the result of like call function A, call function B, and then call function C and give it A and B, maybe you don't need to test that function because you can just really test function C and make sure it knows how to handle A and B, right? Maybe, because maybe A and B are really hard to unit test and have a lot of dependencies, and you can skip that. Fuzzing is a great tool. Most of us don't have a need for it. If you're writing image codecs, do fuzzing. If you're writing like a SIP message parser, you probably need fuzzing. Anything with state machines, it's gonna genetically modify your inputs on your tests and just kind of give you weird stuff, and you'll be surprised by what you catch. If you're doing API request reply stuff, it's not gonna be helpful. Benchmarking is another thing that's built into Go for performance critical code. If you care about your CPU usage or your memory usage or whatnot, definitely make sure you take advantage of the built-in Go benchmarking. It's just a question you have to ask yourself. Is performance critical on this code that I'm writing? Yes or no? If it is, use it. If it's not, you don't. So conclusion, I'm already a minute over. Ryan's gonna give me a hard time about it. Let's broaden our concept of what counts as testing. Let's be strategic in how and what we decide to test. Make sure that we're testing our code and not relying on our customers to test it, because we're the ones getting paid for that, not our customers. They're paying us the money. So it's kind of like a weird inversion if you're like not testing your code. It's like, you need to hold yourself accountable to making sure you're doing your job in a meaningful way. And then testing is not an all or nothing thing. As long as you like making an effort to do your testing is meaningful. It means that you've thought about it. It means that you've analyzed and thought about the risk involved in it. And maybe you decided that it doesn't need to be testing this. It's fine, but at least think about it. Or maybe you decided that like, hey, I'm gonna make sure that it just in my code, I'm like, here's a curl request that you should run against this because it costs a week of time to automate it and it's just not worth it. So it's just that's better than having nothing. Thank you for listening to my random thoughts on testing and